Hello, and welcome to two-variable linear systems using the elimination method. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. This lecture is for Math 1508 Pre-Calculus at UTEP. We're using Larson's 10th edition of Pre-Calculus. This is Chapter 7, Systems of Equations and Inequalities, 7.2, Two-Variable Linear Systems. So using the method of elimination, what we're going to do is first we're going to obtain coefficients for x or y that differ only in sign by multiplying all terms of one or both equations by suitably chosen constants. Now this suitably chosen is probably the hardest part of the method. Notice differ only in sign means maybe I want to make them both 10, but one a positive 10, one a negative 10. And the reason for that is because step 2, add the equations to eliminate one variable, hence the name of the method. Solve the equation obtained in step 2, back substitute, and check our answers. Here we go with several examples. So solve by elimination, 3x minus 5y equals 8, 2x plus 5y equals 22. I see that the y's have the same coefficient, 5, but they're opposite in value. One's negative and one's positive. So step 1 is taking care of it for us. If we add these equations straight down, I'll get 3x plus 2x is 5x. Minus 5y plus 5y eliminates the y. 8 and 22 makes 30. So adding the two equations, step 2, literally just means add them straight down. That's why we always have them in standard form. Step 3 is solve. If 5x equals 30, then x equals 6. Back substitute. If x equals 6, I could substitute into either equation and find my y value. So I'm going to use the top equation. 3 times 6 minus 5y equals 8. That's 18 minus 5y equals 8. I'm going to subtract 18 from both sides. If minus 5y equals negative 10, then y equals 2. X equals 6, y equals 2. We have our solution. And you can check it in the first one. In the second equation. 6 times 2 is 12. 5 times 2 is 10. 12 plus 10 is 22. So we know it works for both equations, and we do have an actual solution. If we have x plus 5y equals 10 and 3x minus 10y equals negative 5, I'd be tempted to use substitution, but we're going to use elimination because it says so. I could eliminate the x's by multiplying the top equation by negative 3, or I could eliminate the y's by multiplying the top equation by a positive 2. When given the options, I always choose to multiply by the positive just because negatives are easily forgotten. We go too quickly sometimes, we forget about negatives. So I'm going to multiply the top equation by 2 to eliminate my y's. So 2 times x is 2x, 2 times 5y is 10y, 2 times 10 is 20. Add straight down, I'll get 5x. The y's cancel out, equals 15. If 5x equals 15, then x equals 3. We can substitute back into an original in order to find the y value. So with x equals 3, in the top equation, I know that 3 plus 5y equals 10. Subtract 3 from both sides. If 5y equals 7, then y equals 7/5. Our answer is the point 3 for x, comma 7/5, our y value. Now, 3x plus 11y equals 4, and minus 2x minus 5y equals 9. They already have opposite signs. The x's have opposite signs, the y's have opposite signs, so whatever. I call it mathematician's choice. You could choose which one you want to eliminate. I've chosen to eliminate the x's for this reason. When it's kind of up in the air, neither one really looks easier. I'm looking at 11 and 5, and I know the least common multiple is 55. Whereas 3 and 2, I only have to turn them into 6. So I'm going to eliminate the x's because it seems like it's less room for error since I'm multiplying by smaller numbers. I'm probably just tricking my own brain there. So I'm going to multiply 2 times the first equation and 3 times the second equation to make 6x and negative 6x. But I can't forget, I have to multiply everything in the equation. Every single term gets multiplied, not just the ones we're trying to cancel. So 6x and negative 6x cancel. 22y minus 15y is 7y. 8 and 27 makes 35, so of course y will be 5. Once we have either one of the first answers, the first answer, y equals 5, or in the previous example, x equals 3, we find the value of the other one that goes with it. With y equals 5, I'm going to substitute in the top equation, primarily because there's no negatives, even though that 11's kind of big. Negatives tweak my brain more than big numbers. 3x plus 11 times 5 equals 4. That's 3x plus 55 equals 4. Subtract 55, divide by 3, and I have my answer. X is negative 17, y equals 5, and I can check it here. Negative 17 times a negative 2 will be a positive 34. Positive 34 minus 25, right? 5 times 5. A positive 34 minus 25 is indeed a positive 9, and we know for a fact this is a solution. If we have 7x plus 8y equals 6 and minus 14x minus 16y equals negative 12, I see the 7 and 14. Oh, that's pretty easy. I'm going to multiply the top equation by 2. The whole equation, I'm going to multiply by 2. And I'll get 14x plus 16y equals 12. Negative 14x minus 16y equals negative 12. But when I eliminate the x's, I see that I've also eliminated the y values. 12 minus 12, that's 0. Now 0 is always equal to 0. This is always true. This is what we call a dependent system. And when we have a dependent system, choose the last variable. So if it's a 2-variable system, it'll be y. If it's a 3-variable system, generally it'll be z. If you're using the standard x, y, z. The last variable, we're going to make that be a for an arbitrary number. For any arbitrary number a, I can solve for x. So using the top equation, 7x plus 8a equals 6. Subtract 8a from both sides. Divide by 7. For any y value you give me, any y value, it's arbitrary, I could tell you the x value that goes with it. And for any y value you give me and the x value I could find from it, it'll work in both equations. This is one of those examples where they're the same line, they just look different, so they're written differently. So this is a solution in which the two lines lie on top of each other, a dependent system. In solving by elimination, a lot of times we could have systems that have fractions or have decimals. Keep in mind you can multiply the entire equation by the least common multiple, the greatest common denominator. Wow! Greatest common denominator, and it'll clear it. In this case, the greatest common denominator is 100. Multiply the top row by 100. Multiply the second equation by 100. 5x minus 3y equals 21, and 7x plus 2y equals 16. Are going to be a lot easier to look at as solutions than finding a solution than trying to deal with the decimals. I don't know why, it just seems like it's easier. I want you to give this one a try. Pause. I suggest you eliminate y, but it's not absolutely necessary to start there. Also keep in mind I could eliminate y, find an answer for x, and then I could come back here to the start and I could eliminate x in order to find an answer for y. Negative 67 over 31. Let's make sure that's the right answer. Let me know if I'm right or wrong when you try this problem. Alright, so what can make systems of equations better? Word problems. So an airplane flying into a headwind travels the 1,800-mile flying distance between Pittsburgh and Phoenix in 3 hours and 36 minutes. On the return flight, the distance is traveled in 3 hours. But keep in mind, Pittsburgh and Phoenix have not drifted from each other. They're the same distance apart, 1,800 miles. Find the airspeed of the plane and the speed of the wind, assuming both remained constant. Now, I have a distance, I have some times, I want to find a rate. So my first thought is that distance equals rate times time. The question or the action statement is always going to tell us what it is we need to do with our variables. How do we label them? Find the airspeed of the plane. I'm going to let P be the speed of the plane. And the speed of the wind. I'm going to let W be the speed of the wind. Assuming both remain constant, alright, I can handle that. Now, if distance equals rate times time, I'm going to get all my distances, rates, and so forth. An airplane traveling into a headwind travels the 1,800-mile flying distance, distance equals 1,800 miles, between Pittsburgh and Phoenix in 3 hours and 36 minutes. 3 hours, 36 minutes. Remember that 36, that's not 36 hundredths, that's 36 out of 60 minutes in an hour. And this is 6/10, so 3 plus 6/10 is definitely 3.6 hours. I know distance, time, my rate. Since I'm going into a headwind, the wind is blowing against my plane. Wind blowing against my cool little airplane here. Alright, so it's slowing it down, and I will have 1800 equals P minus W, distance equals rate times time, and I distributed that. So 1800 equals 3.6 P minus 3.6 W. On the return flight, the distance, 1800 miles, is traveled in 3 hours. In this case, I know that the wind is pushing my plane. Draw another plane. This is a different plane, evidently. It has a bigger cockpit. Man. Little windows on here. Sorry. Focus. The wind's pushing it along. And so I know my speed is the rate of the plane plus the rate of the wind, because the wind is helping us out. So I have distance is 1800 equals rate, P plus W, times time 3. And I can multiply to get 1800 equals 3P plus 3W. I now have a system. So my whole problem forms into 1800 equals 3.6P minus 3.6W, and 1800 equals 3P minus 3W, and that's not true. This last one, right, the wind is helping us out, so that should be 3P plus 3W. And as I solve this correctly, don't worry, the typing is correct, except for that one little typo there, I cut and paste. Rather than multiplying each equation appropriately in order to make my W's the same value, only opposite signs, or whatever for the P's, I'm going to divide the top equation by 3.6, and I'm going to divide the bottom equation by 3, because multiplying by 1/3, same as dividing by 3, that's a legit trick. So we don't always have to make it bigger when we're trying to get equal coefficients and opposite signs. Sometimes we can make it smaller. And when we divide the top equation by 3.6, I'll end up with 500 equals P minus W. Divide the bottom equation by 3, and I'll get 1800 divided by 3 is 600. And on the right, P plus W. Now we have coefficients of W the same, both 1, opposite in sign. When I add the two equations, I'll have 1100 equals 2P. So the speed of the plane is 550. If the speed of the plane is 550 and I subtract something to give me 500, it must be the speed of the wind is 50 miles per hour. It's pretty strong wind up there, but it's pretty high in the atmosphere, so we're alright. An 8-ounce glass of apple juice and 1 8-ounce glass of orange juice contain a total of 177.4 milligrams of vitamin C. 2 8-ounce glasses of apple juice and 3 8-ounce glasses of orange juice contain a total of 436.7 milligrams of vitamin C. Now it sounds like the start to a commercial, but really I want to know how much vitamin C is in an 8-ounce glass of each type. Remember, the question tells us how to label our variable. So, how much vitamin C is in an 8-ounce glass of each type? I'm going to let A be the amount of vitamin C in an 8-ounce glass of apple juice, and let J be the amount of vitamin C in an 8-ounce glass of orange juice. I found that O does not work very well as a variable. Once I know how to label my variables, I go back to the statement of the problem, and it says 1 8-ounce glass of apple juice and 1 8-ounce glass of orange juice contain a total of, so 1A plus 1J, alright, the amount of vitamin C in a 8-ounce glass of apple juice, the amount of vitamin C in 1 8-ounce glass of orange juice, is a total of 177.4. In green, my second sentence says 2 8-ounce glasses of apple juice and 3 8-ounce glasses of orange juice contain 436.7 milligrams of vitamin C. How much vitamin C is in each type of juice in an 8-ounce glass? I'm going to solve this system. And if I solve this system, I'm going to eliminate J for some reason. So I'm going to multiply by minus 3. Negative 3 all the way across, I'll have negative 3A, and minus 3J equals negative 532.2. Leave the second equation alone. I'm canceling my J's here, eliminating. I'll have negative A equals negative 95.9. So positive A is 95.5 milligrams of vitamin C in an 8-ounce glass of apple juice. And we can use the top equation, the original top equation, to find 81.9 milligrams of vitamin C in an 8-ounce glass of orange juice. Last example. A total of $32,000 is invested in 2 municipal bonds that pay 5.75% and 6.25% simple interest. The investor wants an annual interest income of $1,900 from the investments. What amount should be invested in the 5.75% bond? Well, the totals will tell you your equations. You have a total invested and a total annual interest. The question, what amount should be invested, tells you your variables. I'm going to let X be the amount invested in 5.75%, and just because there's two of them, I'm going to use Y as the amount invested in the 6.25% account, keeping in mind I only really want to know X. So, a total invested, if X is the amount invested in 5.75 and Y is the amount invested at 6.25%, then they must add to be $32,000 total invested. Simple interest, annual interest income. It's a simple interest in which 5.75% multiplied by the amount invested will be the amount of return, the amount of interest. So always in percentages, put them in decimal form. 0.0575x plus 0.0625y equals the $1,900 interest income. Now I'm going to leave this one for you to solve. Personally, I would probably use substitution. I'd get y by itself and solve from there. But instead, you can multiply this entire top equation by negative 0.0625, eliminate the y's, solve for x. Either way, you should get an answer of $20,000 in the bond at 5.75%. Therefore, $12,000 in the bond at 6.25%. Try this. Make sure you understand it. Make sure you can get this answer of $20,000. Thanks for listening.